Okay, our next section is 1.4, inverse of a relation. So our starting function is given here, just strange little broken line function that you can't do on your calculator. Goes through the coordinates -5, 1, -2, 1, and the origin, and then up to +2, 6. Another way of giving that would be to give you a table of values and just give you some of those values in the table. So -5, 1, -2, 1, 0, 0, and 2, 6 are the points that I have used to draw this thing. A real common question 1.4 is to first of all draw the inverse, and then we'll be asked, is it a function? So to draw the inverse, you literally switch x and y. So one way of showing that we're going to do this is to say x equals f of y instead of y equals f of x. And we do that with the equation of any relation or function that we're asked to do the inverse of. Just switch x and y. Even with the coordinates, if I do coordinates for the inverse, there will be 1, -5, 1, -2, 0, 0 will remain the same, 6, 2. So I literally switch the coordinates around. X becomes y, y becomes x. If I draw that up above here, if I go to the point 6, 2, 1, 2, 3, 4, 5, 6, 2, I have a point here, 6, 2. 0, 0, as I said, is invariant, so maybe I'll use a dotted line to try to show this one a little different. Instead of -2, 1, I'm going to have 1, -2. And instead of -5, 1, I'll have 1, -5. So 1, -2, and 1, -5. And if I connect the dots and just connect these things, label my points, you can see the final drawing. Now, one way of describing this is that it has been reflected about the line y equals x. Now, I'll try to draw the line y equals x through here. And the line y equals x looks like that. And hopefully you can see that what we used to have above and to the left of the line is exactly what we now have below and to the right of that line. So that's our axis of reflection. A little harder to picture than some of the other reflections we've done, but if you just switch the x and y coordinates, you will right away get the graph you're looking for. Now the second part of this question is it a function? Now if you remember, to test for a function, one of the easiest ways was called the vertical line test. If a vertical line touches your graph in more than one place, it's not a function. And this one definitely is not. There's this vertical section of the graph here, which means that for one value of x, there are multiple different values of y, so the answer is no. The inverse is not a function. For that reason, we won't use the other notation, the y equals inverse function of x notation. That notation is reserved for if it was a function, so we'll stick with this x equals f of y kind of notation.